Okay, this is 7th grade lesson 5.3. Our objective today, students will find unknown measures and similar figures by setting up proportions. The standard covered once again is 7G1. The page numbers are page 206 through 211 out of the hardcover book and pages 115 through 118 out of the practice journal. Okay, yesterday we worked with proportional figures and finding area and perimeter off of those. Today what we're going to be doing is using proportions to find missing measures. Now this is something that I have previously taught, so it should tie in to things that maybe I've introduced to you through bell ringers and stuff throughout the earlier parts of the year. So when we have two figures that are considered similar, that means that their side lengths are proportional to each other. So we can set up proportions. Now I personally like to set up the same figure as a fraction, but as we have worked previously, you can also set up sides that are the same. So if you would rather do 6/9, because those are the same side on each figure, you can do that because that is how we did our previous lesson when they only gave us one side length. I personally like to take one figure, and the reason why is because I'm a visual learner, and visually it is just easier for me to set that up as a ratio and then match side lengths in the second ratio. So you have to decide what you are most comfortable with, but we're going to be working proportions today. So the way that I would go through and I would look at this, when they tell us that they are similar, that means that our side lengths are going to be equivalent to each other. Okay, so when I go through and I check this, I would write it out as 6/8 because I like to do the same sides of of this figure, happens to be a triangle, in the same ratio. Okay, and that is going to be equal to, now I have to match sides. So this 6 is the same as the 9. So I need to make sure that those are on the same level, which I have the 6 on top. So my 9 is going to go on the top. Over x is the same as 8. Okay, so now I can cross multiply, divide. So 9 times 8 is 72, and we're going to divide that by 6, which gives me 12. So I just found out that x is 12 meters. Okay, the other way of doing that with the stuff that we did yesterday, or in lesson, maybe not yesterday, but in our lesson 2, was doing similar sides in the same ratio. So you could have also set it up like this, 6/9, but then you have to make sure that you do the same figure on the same level. Okay, so the same triangle needs to be on the same level. So I would need to do 8 as the top and then x as the bottom. And that's okay to do too. You'll notice that we're still doing 8 times 9 in both of these figures and then dividing by the 6. You have to decide what you are most comfortable with. I prefer the same sides within the same figure. Other people, because of what they previously learned, might like to do the same sides. I like to do the same figure in the same ratio. Okay, but you decide what you would prefer. Okay, so let's go ahead and try another one of those. Okay, so here we've got two similar triangles. We're going to solve for x. Okay, so I'll set it up both ways, but you have to decide what is best for you. Okay, I like to do the same figure. So I'm going to do 22.5 over 15. Now, it doesn't matter if I did 15 over 22.5. I just have to make sure to match. So now when I match sides, my 15 is the same as the 4. So I want those on the same level. So my 15 was on the bottom. I'm going to put 4 on the bottom and x on the top. Cross multiply, divide. So 4 times 22.5 gives me 90 divided by 15 gives me 6. So I just found out that x is 6 meters. Okay, if you like to do it the other way, go ahead. You should still be getting the same answer as me. Okay, so I want you to try this one. So go ahead, pause your video and work your way through this one. Once again, either matching congruent sides or corresponding sides, or setting up your ratio with the same figure. You should have gotten x equals 20 inches on this one. Okay, so that's just working with finding missing side lengths on similar figures. Okay, so now we're gonna take it to another level. Still working with similar figures. Okay, but here this time they're giving us some information. They're telling us the ratio of the perimeters, okay? So it says the two figures are similar. The ratio of their perimeters is 3 to 4. Find the value of x. Okay, so my ratio is 3 to 4, so I'm gonna write that as a fraction, 3 to 4. Okay, so here's the thing. Now, how do I match sides? Because that's a ratio of the perimeter. So to match sides, well, when I look at this, which of these two is the smaller figure? This one, right? Okay, which of these two is the smaller number? This one, right? So I'm gonna put my x where my 3 is. So x over 12. So now we'll go ahead and cross multiply, divide. So if they give you the ratio, then you're gonna have to do some looking at the figures and deciding which goes with which. So 12 times 3 is 36 divided by 4 gives me 9. So x equals 9 feet. Okay, so let's try another one of those. Once again, it's just another way of asking the question. When they're similar, remember they're proportional. Okay, they're similar, their ratios of the perimeter are 7 to 10. Find the value of x. So 7 to 10. Okay, smaller number goes with smaller figure. So 7 goes with my smaller figure x over then 12 with the bigger number. So now we'll cross multiply, divide. 7 times 12, divide that by 10, gives me 8.4. So x equals 8.4, whatever the unit is. Okay, so set up your ratio and then look at your figures, match smaller number with the smaller figure. Okay, so why don't you go ahead and try this one? The two quadrilaterals are similar. The ratio of their perimeters is 12 to 5. Find the value of x. So go ahead and pause your video, set up your ratio, and solve for x. Okay, I just found out that x is 6.25 inches. And I'll double check that, but 15 times 5, and then divide that by 12, gives me 6.25 inches. Keeping in mind, the reason I put the 12 and the 5 in there is I was identifying that the 12, the big number, was the bigger figure, and the 5, the smaller number, was the smaller figure. It was just helping me visually set up my proportions. Okay, matching the bigger number with the bigger part of the original ratio. Okay, so that's working with when they give you at least 3 of the sides that you need, or if they tell you that the perimeters, the ratio of the perimeters, and then give you one side, okay? So now what we're gonna do is we're gonna work a little bit with indirect measure. This is gonna look very similar to the first part of this lesson. Indirect measure is, it's a way that uses similar figures to find missing measures of something that might be difficult to measure. So for example, here, we could approximate the height of that tree by using another figure and its shadow, okay? So what they're doing is they had this 6-foot person stand, and then they measured their shadow, okay? So they measured the person, they were 6 feet tall, and their shadow was 3 feet. They were then able to take that same tape measure or measuring device and measure the length of the tree's shadow as 15 feet. And using those 3 pieces of information, we can approximate the height of that tree. Okay, that's measuring the height indirectly, using another method to find the height of that tree. Notice when we kind of set this up, it does look like 2 right triangles, so similar figures. Okay, the sun is at the same point. That's why this works, and it actually does work. Okay, so, and it gives you an approximation, not an exact answer. Okay, so we're just going through and getting an approximation of the height of that tree. So I like to do same figure, same ratio. So I would set this up as 6/3. And then over here, well, my 15 was the shadow or the bottom number, and that's where my 3 was, the shadow. Cross, multiply, divide. So 6 times 15, and divide that by 3. And when I do that, I get 30 feet. Okay, so that tree is about 30 feet tall. Okay, so indirect measure is just a way of measuring something without actually measuring it. So here we're using shadows to be able to do that. Oops. Okay, so let's do another one. Here we've got the Statue of Liberty, and we've got a person that's 6 feet tall, and their shadow was 3 feet. So 6/3. And then for the Statue of Liberty, the shadow was 75 feet. So that was the bottom of our triangle, or the shadow, however you would prefer to look at it. Okay, we're going to cross, multiply, divide. 6 times 75, divide that by 3, and when I do that, I get 150 feet. Okay, probably not quite as easy to measure the Statue of Liberty, but the shadow, especially if it's 75 feet long. Okay, so let's try another one. So here we have a tree. Looks like the sun's a little lower at this point because the shadow is so long. Okay, so the person, this time we're trying to figure out the height of the person. So probably not as likely to go through and do indirect measure this way because it would be easier to measure the height of the person than the height of the tree, but we can still use it as a practice method. Okay, so we have the height of the tree is 15 and the shadow is 25. So 15/25. And we don't know the height of the person, but we know their shadow is 10 feet. So the shadow was 10 feet. Cross, multiply, divide. So 15 times 10 is 150. Divided by 25 gives us 6. So this person was 6 feet tall. Okay, so I'm going to give you guys one I want you to try. Once again, it's similar figures. It's just another method, indirect. Okay, so here we're going to go ahead and, this one we'll do together because I forgot this was one that involved inches. So it says the shadow cast by a 1 foot ruler is 8 inches long. So 1 foot, so I'm a very visual person. I'm going to go ahead and draw a picture. So it says the shadow cast by a 1 foot ruler. So this ruler is 1 foot tall and the shadow was 8 inches long. Okay. All right, it says at the same time, the shadow cast by a pine tree. So here's our pine tree. Great picture, I know. Beautiful picture. So there's our pine tree. And it says the shadow is 24 feet long. So the shadow is 24 feet. What is the height in feet of the pine tree? So here's the thing. We have one of these in inches and everything else is in feet. You're going to want to change this 8 inches into feet. Now, granted, it's not a whole foot, so it's a portion of a foot. So the way that we can change that into its decimal form is to divide this by 12 inches, which is the same as a foot. Okay, so we're doing some converting. So 8 divided by 12, it's going to give me a portion of a foot, which is 0.6. Repeating. Okay. So if I go through and I set this up, it would be 1 over my 0.6 repeating. And then that's going to be equal to 24 was my shadow. Okay, remember, this is an approximation. So when I punch this in on my calculator, I'm going to hit as many 6s as I can here. Otherwise, I could set it up as a fraction, 8/12, which would be 2/3. I could set it up that way. I don't like to work fractions if I don't have to. And once again, indirect measure is an approximation. If I was doing this, I wouldn't need to know the exact, I'm going to round anyway. Okay, so I'm going to take 24 times 1 is 24 and divide that by 0.6. So 24 divided by 0.6 repeating as many times as I can get it on there gives me 15.9999999. So that's approximately 16 feet tall. Okay, once again, it's approximation. Don't worry if you have to work. I personally wouldn't go through the steps of doing all of the fraction parts if I was doing this in the real world. Okay. So let's try another one of those. A building casts a shadow of 420 meters long. So a building, here's my building. I know you guys know I'm an artiste. There's my building, terrible windows. And it's 420 meters long, casts a shadow. So this is 420 meters. At the same time, a person who is 2 meters tall, so here's my person, and they are 2 meters tall, casts a shadow of 24 meters long. And I know my things do not look proportional. But anyway, we're just using it to get the information. Okay, so I've got person is 2, over shadow is 24. Actual object is, I don't know, over 420. Cross multiply, divide. So 420 times 2. And then we're going to divide that by 24. And when I do that, I get 35. So this building is 35 meters tall. If I did that right, let me double check that. 2 times 420, divide that by 24. Yep, 35. Okay, so that's working indirect measure. So I'm going to draw one of my awesome pictures. And I want you guys to find, and you may get a decimal number, so just round it because I'm just coming up with this off the top of my head. So we have this beautiful tree. I know, I am such a great artist. And I don't know the height, but I know that the shadow, when this beautiful sun over here casts its shadow, the shadow is, we'll say 10 feet long. Okay, then I have this little person over here. And they're, we'll say 4 feet tall. And they cast a shadow of 2 feet. Okay, I want you to go ahead and find the height of that tree. So go ahead, pause your video, set up your ratios, and find the height of that tree. You should have gotten 20 feet tall. Okay, so that's it for this lesson. Key thing is working with those proportions, indirect measure, setting them up, matching. For me, I just match shadows and people together or objects together. Okay, the previous part was working with proportions for finding those missing measures, so that cross multiply divide. If they give you the ratio of the perimeters or the areas, is going through and actually working off of it that way. Okay, so I want to jump to one more thing that I forgot that I had on here, and that's using proportions to find an area. There's one thing that's slightly different, and that's the fact that if they give you the area, when you set up your proportions and reduce them, remember you have to square. Okay, which we practiced earlier. You have to square that area. Okay, so here it says a swimming pool is similar in shape to a volleyball court. What is the area A of the pool? Okay, so here, if I were to do the ratio, I'm going to go ahead and set this up, the ratio of each of these to each other. Okay, so if I set that up, I'm going to do 18 to 10. It doesn't really matter. We'll do 18 to 10. Now, because I am working area, I have to remember the steps that I did in our previous lesson, and that's I have to reduce, and then I have to square. Okay, so if I reduce this, it would become 9 over 5. Now, remember, it's area, so we're going to square that before I can do anything else. Okay, so if I square it, I get 9 squared is 81 over 5 squared is 25. So this is what I'm now going to use to solve and set up the proportion. Okay, so the third bit of information. So my 81, this was my swimming pool, and this was my tennis court. So my tennis court area was 200. So my area was 200 on the tennis court. I'm going to now cross multiply divide. Okay, so I still get to use proportions, but I have to go to those extra steps to get the side lengths into that area format like we did in section 2. Okay, so 200 times 81. Now I'm going to divide that by 25. And when I do that, I get 684. So this is 684 yards squared for the area. Okay, so let's practice another one of those. Once again, it's tying two things together. So it's tying in that area proportions and then also solving for a missing number. Okay, so it says the area of rectangle B is 75 centimeters squared. What is the area of rectangle A? Okay, so we're going to take our sides and set them up as a proportion. Okay, so I've got 3 to 5. So this was my A, this was my B. Okay, now I'm doing area, right? So what do I have to remember to do? Square this. It's already reduced, so I can't reduce it. So I'm going to square it. So 3 squared is now 9 over 5 squared is 25. Okay, so now I get to use 9/25. So my third bit of information now is, whoops, that's an equal sign, is the area of B was 75. So B was my bottom number. We're going to cross multiply, divide. So 75 times 9 divided by 25 is going to give me 27. And then centimeters squared. Okay, so one extra step. We have to remember, take those ratio sides and square them. Okay, so I'm going to give you guys one to try. Okay, the area of the shaded triangle is 36 meters squared. So I'll just write that on here. So this one is 36 meters squared. What is the area of the non-shaded triangle? Okay, so first step, take your sides of those triangles and set it up as a ratio. Reduce it, square it, because it's area. Okay, then you can work the proportion. So go ahead, pause your video, and work your way through this one. You should have gotten 64 meters squared. Key thing out of this whole lesson is making sure that you're matching sides. So make sure that as you set up your proportions that you match like sides, either on the same level or within the same proportion.